Okay, so let's get going then. I'm sure there will be a few more people that end up dialing in, but I know we just have to bear with whatever challenges we are faced here. So welcome everybody, and welcome to your weekly drone dates, our fireside chat on Women in Drones Africa. And as usual, we are coming to you from various locations. And last time we had our friend Dean Polley on, we were actually talking about the very same things. Do you remember, Dean? You lost power and then eventually you dialed in on the phone and we were letting you do your presentation, speaking through the phone, and the speakers. I think Sharon at that point afterwards said to me, "You guys are like just so calm through all of this. You're just like industrious and you know, deal with these things." And I think, we try, definitely. So Dean has been on Fireside Chat a few times, but he always comes up with cool projects and case studies. Last time he shared with us his experience in using drones to drive back elephants from villages and preventing elephant-human contact, which is not always with positive outcomes. So that was super interesting. And tonight, Dean's going to be sharing with us a very cool case study, which essentially just demonstrates the fact that it's not just about putting a drone in the air and getting a survey done as easy as that. And Dean always has the most amazing ability to put very cool slideshows together with very compelling imagery and information. So Dean, thank you for agreeing to do this case study for us on Women in Drones again. And the floor is yours.
Thanks, Kim, and welcome to everybody. For those of you that dialed in a little bit or connect a little bit late, Louise just asked me about an annual photographic competition that whether I'd entered into that. So I mentioned that I submitted a couple of photos and 2 were selected. So every week for, I think it's about 4 months, every week they select a selection of photographs, and at the end of the competition, which is the end of April, they will then whittle them down to the top 100 and then the 50 and 30, and then finally usually the winner, the runner-up, and then 10 highly commended. So if you'll allow me quickly to host disabled participant screen sharing. So if you can allow me to share my screen, which I'm going to need for the presentation.
I think, Louise, you have to do it. I can't do it from my side.
I'll make you a co-host. Then you can. That should work.
Lungasani says she can't hear anything.
I'm on it. I'm messaging her.
Okay, so I'm going to just very quickly. That was one of the images in week 4.
Oh, wow.
I don't know if you can see that screen. So for those of you not familiar with snakes in Africa, this is one of the deadliest snakes in our area, a Mozambique spitting cobra. I don't know what to say other than it's just lethal. One of my other hobbies, if you want to call it that, is the small game reserve that I stay on. I'm the local snake wrangler. So I get called out when there's snakes. And this one particular specimen that I photographed earlier in the day, I actually removed it from somebody's lounge. It was in their coffee table. And so it took me a while to get it out. I caught it. And then I thought, well, before I let it go, let me just take a nice photo of it. I submitted it and it was then selected. The other one, let me just kill that. The other one was just off my patio, a little weaver that was started building its nest. It's one of these impromptu photos. I took the photo and I thought, oh, it looks okay, let me submit it. And that was in the first week and that was selected. So there you go. Okay, let me get on to the topic this evening, or this afternoon, or the morning, wherever you may be. You should see a screen there.
Yep.
the opening screen, precision photogrammetry. Everyone see that?
Yes, perfect.
Okay. Right, let's get going. So first of all, I think there were a couple of you on the call last year sometime when I discussed photogrammetry with the underground mapping and the inspection drone. If you weren't on that call, just very quickly, what exactly is photogrammetry? It is the science of measuring from images. The primary input is overlapping images over a particular area of interest. And your primary outputs include accurate measurements and 2D orthophotos and 3D point cloud representations of the area that you've really surveyed. So you can identify the same thing. If you can identify the same thing in at least 2 images, and you know your camera's external and internal parameters, you can then compute a point's position in 3D space. So when we talk about a camera's external parameters, this typically defines the position and the orientation of the camera. So DJI Phantom drones, or most drones, navigate via using GPS location. And when you are flying an aerial survey and they take a photograph, the position of the aircraft at that time is recorded in each image in its EXIF data file. And the orientation of the camera is either nadir, where the camera is looking straight down, or oblique, where it's between 30 to 45 degrees, so that you pick up imagery on the side of buildings and get a lot more, just a better 3D representation. Then the camera has internal parameters, which are really important, and you'll see a little bit later on why. They define the geometries of the camera's lens and the sensor. So every camera, of course, has a sensor, but you have different types of sensors, different sizes. And then the camera's lens, usually it's a fixed focal length lens, and combined, these will determine what is ground sampling distance, or GSD, which is what determines the accuracy in measurements when you are negotiating or exploring the end process and project. So just in simplistic terms, any point in space, it's like if it has an overlap of 2 images, that can be computed as a point in space. And usually, I want to move on, there you go. And this example, it can be more accurate if you have a 3rd image, and going forward, you'll see multiple images will allow you to, with those parameters of the camera, you'll be able to calculate or compute a point in space. So GSD, so those of you that have ever taken a photo and you try and zoom in and your camera was set to a low resolution, on the right, you will typically, as you zoom in, you will get that kind of effect called pixelation. So as we know, every digital image is made up of literally thousands of pixels. And the more dense the pixels, the higher your ground sampling distance is. So looking at the same image, but with different resolutions, you will see that this is a very fine ground sampling distance of 2.5 centimeters. And this is a very coarse one of 25 centimeters. So why exactly is that important? So when it comes to measurement, so this is the case study that I'm going to go through. This was a company that manufactures hollow core prefabricated concrete slabs, and they needed a very high accuracy. And when you process, so this is the ortho mosaic that was processed, and the Pix4D Mapper quality report will tell us that we got a ground sampling distance of less than 1 centimeter, 0.74, which is actually quite astounding. Usually in survey terms or surveyor terms, anything from a 3 Gsd and 3 centimeter Gsd or higher or lower is determined like super cool. So to be able to achieve it less than 1 centimeter is just astounding. So what is Gsd? So if you had to zoom into an image and you could get to a point where you can see every single pixel, the Gsd is the measurement from the center of 2 adjacent pixels. So in this case, there is the center of your pixels, and the measurement between that is your Gsd, and in this particular case is 0.74. So why is that important? Let me demonstrate that with a picture going forward. So ground sampling distance is determined by primarily 3 things: the altitude of the camera from the point of interest, obviously the sensor resolution, and the focal length of the camera. So a shorter focal length will obviously give you a much wider focal point of view on a focal view on the ground, whereas a zoom camera will usually give you a more narrow focal distance on the ground. So I'm not going to expect you to understand that, but typically, well, that is the formula for calculating ground control, ground sampling distance. And just to make it simple, we have something called a Gsd calculator. So this is just a spreadsheet. I mean, there's a lot of them around. You can Google them. I created this one for myself. And what was important in this particular case study is before you go in to do an aerial survey, you need to determine first what is the desired ground sampling distance. So in this case study, we did the opposite. We had no idea. We took drones, we tried different drones, different overlaps. We flew at different heights, and eventually, after processing tens of thousands of images, we eventually discovered, well, hey, this combination works great and gives us the best ground sampling distance. So obviously, that's not the most efficient way of doing it. So there's a much more efficient way of doing it. So the first thing you do is you determine the sensor width of the camera. So you can find that out depending. You can go, for instance, we used a P1 camera, the DJI Zenmuse P1 camera on a M300. You can go to their website, you go to their technical specs, and there we have the sensor size. It's 35.9 millimeters by 24. So we want the width. So we go in, we key in 35.9 millimeters. The next one is the focal length. And the P1 has 3 different camera types. The mid-range one has a fixed focal length of 35 millimeters. So we put in that. We decided to fly at 120 meters above ground level. And the image size, so if we go back to the specs, that's the sensor size. What does it produce? It produces a JPEG file. Where did I have it now? I did have it here. There we go. It gives you a JPEG with a size of 8,192 by 5,460 pixels. So we want that value over there. You key that in, and it'll automatically calculate. And with that combination, we'll achieve a ground sampling distance of 1.5 centimeters. So just to demonstrate how it changes. So let's say we wanted a smaller Gsd of 1 centimeter. Just by changing your altitude and dropping down by 20 meters and flying at 100 meters AGL, you'll see that it has improved. It's now 1.25. If I go a further 20 meters down and I fly at 80 meters AGL, you will then achieve a Gsd of 1.1, exactly 1 centimeter, which is incredibly fine. So 10 millimeters So now that we know, let's say the client has a requirement of, we don't need anything more or less than 1 centimeter. I mean, 2 Gsd will be fine. You can actually go and change that to 120, the flight height. And what advantage that will give you is the higher you go, the larger area the camera is capturing on the ground. So you can fly a shorter flight time and have less images to process. So there are trade-offs and spin-offs. There are pros and cons in changing your flight altitude. And it's all driven around what type of accuracy that your client wants. So just to give you an example, I have another calculator where we took the parameters of a DJI Phantom 4 Rtk. So obviously it has a different camera and a different focal length. And given all things equal, flying at the same altitude, you'll see that it will only give you a Gsd of 2 centimeters. So even at flying at the same altitude, just with a different drone and camera will affect your Gsd of your aerial survey. So, as I said, that looks very daunting, but as I said, you don't need to worry about that at all. And I've just gone through the ground sampling distance calculator, and that's just a visual representation. So the closer, so with all things equal, flying closer to the ground will give you a much denser Gsd or a smaller Gsd. Flying higher will give you a bigger Gsd. So what was the case study? We were approached by a company, and if those of you that have ever in days gone by, when you built a multi-story building, in order to put the concrete layers between the different levels of a building, they would use scaffolding and put out some kind of a metal sheeting, and then they would bring in a truck and they would pour concrete onto the building. And so they would do that for every level. So one of the companies in South Africa produces these, what they call hollow core concrete slabs. So they produce these in fixed lengths of, I think it's about 50 or 60 meters. They have a fixed width and a fixed height. So what they do is when a client completes the first layer or the first level of the multi-story building and they now need to throw a slab, instead of doing it the old-fashioned way, they send a person on site and they measure this building and basically take a drawing of this back to their drawing office. And they will then, with special machinery, they will cut the slabs exactly to size at the factory and then load them on a low bed truck and transport them to the site, and then place the concrete slabs in position for that floor. And then they can carry on with the next level of the construction. So now, can you imagine getting that wrong? So they came to us and said they need an accuracy of no less than 40 millimeters. That's 4 centimeters. And the reason for that is if you take a standard brick wall, that's a double brick wall, it's approximately 26.5 or 265 millimeters with mortar in between. And the concrete slab, when you place it, needs to sit nicely on the inner layer of the bricks. And the reason for the 40 millimeter is that is the width of the mortar between the two bricks. So that is the tolerance or the error tolerance that they can handle. So if you get it right, you then can continue with the outside part of the wall. The slab is inside, and you can continue obviously with the wall going up. If you get it wrong, and the slab is 1 centimeter too long, you have this situation where you now cannot continue with extending the outside brick wall because you have this, you have the concrete slabs in the way. Alternatively, if you have it too short, then it doesn't sit and it's not supported well on the inner part of the wall. And worst case scenario, if you got it completely wrong, the slab would fall in, so it wouldn't sit on the wall. So, and that has happened. The reason this exercise was prompted, because that happened quite often, and they only discovered that on site when they placed the concrete slabs, and it resulted in them having to take the concrete slabs all the way back to the factory, which is a huge expense, both in a waste of time. The concrete slab then has to go into a stockyard, such as that, and then they have to cut the slab again and get it right and take it back to site. So, you know, it's travel, it's fuel, it's time, and it's just totally inefficient. So just to go back, that was the stockyard. This is ortho photo of the stockyard. Each one of those little gray blocks is either a concrete slab that's been cut and ready to be shipped. And in these cases, these are all waste. So what happens is they go into an inventory, and when they get an order for a particular size, they have to go to their waste inventory to see if any of these concrete slabs fit into the parameters of the order, and then they would go and retrieve them from waste stock, as they call it. But you can imagine, if you look at what they're paying for these concrete slabs, it's in rand terms, it's hundreds of thousands of rands of stock just lying there, which is wasted material, which obviously is a loss in revenue. So in the beginning stages, we weren't really sure how to tackle this. So these are the platforms that we tested. We tried a Phantom 3 Pro, a Phantom 4 Pro, a Mavic 2 Pro, a Mavic 2 Enterprise Advanced, the Matrice 300 RTK with the Zenmuse H20T camera. That's the one with the 3 cameras. It's got the zoom camera, the wide angle, and the thermal camera. And then the Zenmuse P1, which was specifically designed and developed by DJI for photogrammetry and for aerial mapping. And I was supposed to ask you the question, and I've moved ahead of myself. So the question was, which one of those do you think performed the worst? And so I gave the game away. It was not necessarily the aircraft, it was the camera. The Zenmuse H20T, which is a very expensive and a highly capable camera, proved to not be the right camera to use in any form for aerial mapping. It was actually quite disastrous, to put it mildly. So that is the end result. We flew a standard aerial survey grid over the area, and that was, those of you familiar with Pix4D Mapper, when you import your images to start processing, it'll superimpose them on a map to show you the position of the cameras. And then we used RTK. So the reason why, so what is RTK, first of all? So most consumer drones do not have a survey grade GPS. So if you rely on the drone's GPS for precise positioning of a captured image in geospatially, it will be out sometimes by up to 2 meters. So you use something called a RTK base station. You set this up prior to the survey, and what that does, it gets, so this is a survey grade GPS. It'll get its constant position, and it'll talk to the drone, and it'll keep correcting the drone's GPS with exact precision. So that way you can do a very accurate aerial survey without having to put ground control points. Because usually if you fly something like a Phantom 4 or just a normal drone, you would have to survey a number of ground control points in your surveyed area. And then in post-processing Pix4D, you would correct the errors of the GPS of the drone with surveyed ground control points. So on the left, this demonstrates the kind of drift that you would have if you relied solely on drone's GPS for positioning. Whereas with an RTK, it'll give you exact positioning of that image on Earth. And I mean, the reason why you would use RTK as opposed to ground control points in this place is in this scenario is because the area is too dynamic. So we didn't have time to place ground control points. We had a constraint of time because those slabs are being moved around all the time. So literally after half a day, your ground control points would just be useless. So looking from the top now, every little green dot represents the position of a camera. And we flew with quite a high overlap. And what I mean by overlap, if I had to put it diagrammatically like this, Pix4D, when you fly an aerial survey, you typically fly in a grid pattern. And when you capture images, they've got to have, the images have got to overlap. There's got to be quite a substantial overlap. So best practices dictate in Pix4D Mapper that you need a front overlap of 80% and a side overlap of at least 60%. And just to demonstrate what that looks like, so as you're flying, you would capture, you're flying in that direction, you capture your first image, your second image would need to overlap that image by 80%. And that's what is determined by your 80% front overlap because you are traveling in that direction. So when you get to the top and you turn around and you fly back, the same applies. You take your first image, second image will overlap 80%, but now you have a side overlap of 60% on this line of images that you captured in the first flight path, and so forth throughout the survey. So you can see now that in each image overlap in this area, you would have a lot of common features on the ground that would be contained in every image, and that's what determines the quality of orthophoto in your 3D point cloud. That's just a side view. So if you now tilt the image in looking at it from a 3D point cloud point of view, you can just get a sort of side view of the images. Okay, so going back, so once we had done the survey, we then went manually and we selected random blocks and we measured them manually using a tape measure, and we then recorded, we marked the blocks and we recorded on a piece of paper the measurement that we got using the tape measure. And so now we have done that independently of the actual Pix4D Mapper project. So at this stage, there's no correlation between the manual measurement and the actual survey. So once we had processed the project and we now have a 3D point cloud, we went to those respective blocks that we had measured manually. And in order to generate a measurement, you would create what's called manual tie points. So you would zoom into this model and you would click on the edge of the slab, and then you would connect your manual tie points with a Polley line, which is a standard measurement feature in Pix4D. And I don't know if you could read that there, but it says 4.95 meters. So how do you get to those that particular, or how do you do that measurement? So anywhere in your 3D point cloud, wherever you click with your cursor, it will show you the corresponding images where that point in the point cloud is represented in each of those images. So on the right here, you can now see I clicked on the corner of the slab, and if I press my space bar, which I hope I did that, you would then zoom into that image. So you could then go and mark, when you mark your manual type point, you'd be able to zoom in quite close. I think I could get, see, there we go. So that's what it looks like, where you zoom into the actual image and you click. It's a tool in Pix4D Mapper, and you mark your manual type point. So now you can see, I'm sure you can see the pixels. This is a ground control or a GSD of 0.74, which means my margin for error, if I had to click 1 pixel wrong, my error would be 0.74 centimeters, or 74 millimeters would be my error. If my ground control sampling point was 3 centimeters, that would be my margin of error, because it would mean the distance between each pixel is now 3 centimeters. Or if you flew with too high with a Phantom 4 and you got a GSD of 5 centimeters, your margin of error would then be 5 centimeters. So if you could imagine the distance between those pixels, the GSD would determine your margin of error. So if your client, in our case, had a minimum tolerance of 40 millimeters, which is 4 centimeters, we could not have a GSD of less than 4 centimeters. And to get absolute accuracy, we needed the smallest GSD possible, which in our case was 0.75 or 0.74 centimeters. I hope that all makes sense. So when we've now connected the polyline, as I said, Pix4D will automatically measure that. It'll give you the measurement. And when we went back to our manual measurement, it was what we measured was 49.45 centimeters. Sorry, 4.945 centimeters. And the Pix4D is 4.95 meters. So if you had to round it up, in this case, we were actually spot on by a millimeter. 1 millimeter accuracy as opposed to 40 millimeters. So it was a fantastic result to try to get that, that level of accuracy. So we did 2 exercises. First of all, we processed this in Pix4D Mapper on the desktop, and then we also processed it in Pix4D Cloud. In this case, it was Pix4D Cloud Advanced. And we repeated the exercise with measurement. And when I went to measure this, I don't know if you can see that, it's 4.944, give or take a millimeter. So utilizing either Pix4D Mapper or Pix4D Cloud, we were getting the same result because of the GPS positioning of using the RTK base station to provide absolute precision. And then while we were there, well, while I was busy with this, I noticed a 40-foot container, and just for the hang of it, I worked out, well, what is 40 feet converted into meters, and it's 12.92 meters equals 40 foot. So I measured that, and it was 12.182. So we're out by 2 millimeters or 2 centimeters. So it was supposed to be, there you have it. So 40 foot is 12.192 millimeters, which is 12.192 meters. And my measurement was 12.182. So we were out, yeah, we were out by 10 millimeters. So as in a summary, looking at this, so we had 6 blocks that we measured. And this was the difference between the manual measurement and the surveyed measurement in Pix4D. And overall, we had an average difference of 3 millimeters over the entire site. Bearing in mind that the deliverable was a maximum of 40 millimeters. So I'm not sure why there was such a big difference with this one. We actually went to go measure it again, and I think I had clicked on the wrong pixel, and we actually brought it down to about 3 millimeters. So that particular survey we did again at 80 meters, so at 80 meters we got 1 GSD. We actually flew it at 60 meters, which is how we got our 0.74 GSD. So just an illustration, all things being equal, that is the camera, the focal length, the sensor. Just by flying at different altitudes, you can see that the area that you cover is smaller the closer you are to the ground, and the further you go away, it's larger, and that has a direct impact on your ground sampling distance, or GSD. And there's just the Gsd calculator to verify that. Okay, so looking at all the drones, it was interesting to note that the Phantom 3 and the Phantom 4 Pro gave the same results. We were able to achieve a 1.37 GSD. The Mavic 2 was actually better, Mavic 2 Pro. The Mavic 2 Enterprise Advanced was not as good. Of course, I mean, look at this, 5 centimeters with the H20T. And then, of course, the better result was, just kill that, was with the P1. And this was done flying all at the same altitude, and you can verify it there. It was all flown at 80 meters. Okay, so as I said, this was our project was done with Pix4D Mapper and Pix4D Cloud. And Pix4D has a number of applications in their suite today. Moving forward over the next couple of years, this product is going to eventually supersede Pix4D Mapper. In fact, these two products together. So Pix4D Matic is already available on the market. It's basically the new Pix4D Mapper on steroids. So it's been designed to process a lot quicker, and it processes very large data sets. And then Pix4D Survey does your vectorization, does your linear measurements, and does your volumetric measurements. And Pix4D Survey would then export those outputs to a third-party application such as AutoCAD, Autodesk, etc., etc. Pix4D Fields is specifically to process multispectral data to create NDVIs, or normal difference vegetation indexes. Yeah, and our latest product from Pix4D is actually a hardware product. So this is an Rtk cradle that you fit an iPhone 12 or an iPhone 13 that's got the LiDAR, and you can do accurate handheld surveys, as accurate as very expensive what's the Optron stuff now? Total stations, sorry, total stations. It also provides for measuring ground control points. So this is a lower cost and highly effective alternative to expensive total stations from organizations like Leica, etc. And then just, this is who we are. My company specializes in delivering turnkey solutions. And the name is derived out of a business model where a solution for precision aerial survey and mapping, we look at the sensor first of all, what is the appropriate aircraft, there's software involved, and then we either provide we deliver it as a service, or we provide training in all of the technology. And that's my story. I hope am I on time, Kim?
Dean, you did perfect. It's 1:15, and I'm sure we'll have some questions. I think some of the chats coming through, very impressive. There were some questions, Dean, so maybe let's get going. And anyone on the chat, please feel free to put up your hand and ask a question direct or paste it here. Let's quickly see if we have the first one. Yeah, so when you were saying, you know, about cutting those slabs wrong, Desi was saying, yeah, you wouldn't want to get that wrong. No pressure. Desi was asking the question, can concrete be added to or shaved if they are the wrong size? I think the answer is no, but I wouldn't know technically why.
If the slab is too long, then they would be able to cut it. If it's too short, they would not be able to add onto it. Just the nature of the product. So that was why it was very important for them to get the accuracy of the slab measurements like really, really accurate. The process that they go through to create that slab, you would not be able to add on to that.
Dean, I think what I picked up, and because I know you know we've discussed this presentation before, that the team manually measured the test blocks. But yep, it's important for everyone here to know that the company's current way of measuring is an employee, a human being, walking around with a laser pointer, laser measuring device. And those waste piles are actually slabs that are incorrectly sized. So the wastage cost is huge. And like Dean said, the cost of transport there, realizing it doesn't fit because it needs to be cut or wasted, transporting it back, and then sifting through those ones to see whether there's one that can be cut for a smaller size. So you can imagine the inefficiencies.
But also the other impact is you impacting your client's construction schedule, because now they can't continue with the next phase of the construction until you've brought back the slab with the correct size. So it's got quite a big impact.
Mm. Yeah. Desi, there's another question. Do you use P4 Pro RTK, or is the M300 your go-to drone?
Well, we don't have a P4P RTK. We use the M300 because it's so versatile. I mean, M300 would be the way to go with the P1 camera. As of 2 days ago, we also now can supply the Wingtra, the VTOL fixed wing, which is pretty accurate as well, because that flies with PPK and RTK. I just saw a question here, I think it was Desi, about the chart online. Sorry, which chart were you referring to? Was the Gsd calculator?
Yeah, I think Desi, oh yeah, that was right in the beginning when you were showing that. You said you'd created that yourself, right?
So Desi, if you can hear me, you can just go and Google Gsd calculator, or I think, let me see if I can go to Pix4D, Gsd calculator. They have their own, I think that's where I got mine, calculator. There we go. If you go, it's on the Pix4D site. I will actually copy and paste that link. There it is.
Oh, perfect.
So I will go. You can download it. It's an Excel spreadsheet. Where's the chat? You go. Incidentally, at the start of the call, I put those 2 links to the Africa Geographic link to go view those photos and some of the other magnificent photos that are there. So at your leisure. Okay. Yeah, excellent. Pressure, very impressive. Yep. Any more? I don't see any more questions, Kim.
Yeah, so let me just ask some of our newbies into the industry. Chupiso, hi, sweet pea. I think Anela's dropped off. Hi, how are you?
I'm good. How are you?
Good. So yeah, and Pumi and Tembisile, any of you who are new to the drone industry, did this make sense? Does it land? Have you learned from it? Is it interesting? Just give us some feedback. I'm just always interested when there's something as technical as this, whether it is actually useful for you guys.
I think on my part, because I joined a bit late, I think I joined like at 6 o'clock or something. So I missed a lot of the information, but I'll wait for the video and then the YouTube video. So go through it. Yes, I'll go through it.
Okay, all good. Yeah, so Dean, I know you and I've chatted about this before, and this is just around how the clients, given this information, I mean, it's a complete no-brainer, right? To have technology like this as part of their workflow, given the fact that it can literally eradicate their error rate pretty much completely. And yet the conversations around the cost of the drone service versus the cost of their human being and the vehicle and their laser pointer and clipboard, the accountants just weren't getting it. And so the conversation that, you know, we are often having in South Africa in the drone circles, and Dean and I have had this conversation many times, is that this should be part of a company like this. It should be part of, or any organization who is reliant on accurate measurement, for example, in this case, it should be part of their workflow. Like, it's just a no-brainer. And yet it's new technology, and the cost line in a larger budget, when you have the accountants look at this, you know, they say, but this is, you know, X amount of thousands of, you know, rands a month more than what we pay this person. And then the conversation goes, but what about the wastage? Oh, but that we've written that off. Very interesting. And I wonder for some of our colleagues from the US, whether you've ever had conversations like that with a client where they're just not, you know, they want it, but from a cost perspective, the guys that have to make the cost decisions aren't quite there yet. I wonder if anyone has comments.
These are the most frustrating business conversations I've ever had in my life, because they want only to make money, and they really have no regard for waste. There's no regard for waste. It's show me how we're going to make money, and that's really the only conversation they want to have. They don't want to have conversations around waste, and it just eats my soul when we have these. I cannot even describe, because you think about social responsibility, just plain and simple, when you want to have conversations about volunteerism, or you want to have conversations about donations, and you can't because you haven't made enough money, or you haven't made your percentages, or you haven't made your goals. And then equally, they don't want to have conversations about this waste.
Yeah.
And you just try to balance it out. And it is the most frustrating conversations on the planet, because every business case is centered around, show me how much money we're going to make.
Yeah.
And they don't want to have conversations about waste. And it makes me want to rip my hair out. I have been in so many meetings like that. Yes.
If I may, Kim, what was interesting about this exercise as well, so first of all, the current modus operandi was a team of guys driving from site to site, using a laser to do the measurements and drawing their interpretation of the building, going back, giving that piece of paper to the drawing department, and they having to replicate it manually in AutoCAD or Autodesk. So that was their process. So not only did we offer them a solution from an accuracy point of view and a convenience point of view, we added further value. So the further value was, you now have a snapshot, and can you see my screen?
Yep.
This is in Pix4D Cloud. So for a given site, you can have multiple surveys of that site. If you look at the timeline at the top there. So they now have a visual representation of the site, because what's also happened is, after the little guy on the ground has measured, the construction team would make changes, and that would have an effect when they delivered the slab. And there would then be an argument about, well, who's responsible? He would say, but it wasn't like that when I was here. The construction company would deny it. And by default, the slab company would take the hit. Whereas now you have an absolute snapshot of the area that you surveyed. So it's now, there's nothing to argue about. If you go back and there was an anomaly, you can pull up the record and you can see, that is what it was like on that day at that time. There's no argument. Secondly, once you've processed this, you output Pix4D as a standard output to AutoCAD. So you output your shapefile or your object file or your DXFW file. So your drawing department doesn't have to replicate or draw the site manually. They just get it straight from Pix4D. So that was all the value add on top of just the actual measurement. But what the guy was doing, he was measuring his cost of the guys running around measuring against the cost of the service and the facility, and the cost of our service facility was higher than his current cost. And that's how he made a decision on which way to go. And it's just like, well, don't you see the value add? And now you're opening this up to, you can share this. You go and you click share, and you can send this link to anybody. In fact, I will just copy this now, and I'll share it with you all. If you click on that link now, you'll open this exact same, you'll open this project, and you'll be able to navigate around it. And that's how simple it is to collaborate on this project. So, yeah, you sit there, and after that, you don't know what more to say. Then, well, if you don't see the value of that, then I really don't know what more to do for you.
Yeah, I think, Dean, I was having a conversation with someone else in the industry the other day, and she was saying to me, when am I going to be able to stop doing these proof of concepts? I've already proven myself. Surely I can't still be doing proof of concepts and demos. And I said to her, you're not proving yourself. They are proving this to themselves. The end client, sometimes has this kind of information, whoever that person is in the organization, and through budgeting reviews and cycles and year ends and you know, a number of meetings and a number of, you know, what's the, you know, reports and what have you, they have to demonstrate this to themselves and convince themselves that this is necessary, and they do come around to it. But yeah, the technology is still new, and a lot of people just haven't moved with the times. So yeah, this is just a brilliant case study, because it is just a no-brainer. Like you say, what else can you say in the client meeting? You're like,
I mean, on the upside of all of this, this was a really interesting learning curve. And you know, going forward, we can now talk with conviction when we have a similar project. It might not necessarily be measuring slabs, but if somebody came and said, we need some building foundation or whatever needed to be measured, you know, what kind of accuracy could you provide? We could, with conviction, say, we will do it at 10 millimeter accuracy, guaranteed. And we would go to site today and we would fly it once, because we would go through this exercise first, based on what we are planning to use, and we will fly it once, bang, that's it. We won't waste any time. So it did have some value, but it had more value to us at the end of the day than to the client. So I think that I hear what you say about proof of concepts. Kim, as you know, with aerial surveillance and security, they always want you to come and demonstrate it on their site. And regardless of the number of videos that you have of what you've done on another site, they somehow don't get it. It's like, you must come show me. I want to feel and touch. It's same kind of thing, right? So yeah, you do get to a point, if you do proof of concept, you get to a stage where you know that you can do it. But in an instance like this, don't shy away from a proof of concept where you can learn and prove it for yourself as well, that if the client rejects it, well, at least you know what, going forward, I don't have to justify or question this anymore. I know I can deliver. Yeah, absolutely. And we no longer do free demos. Sorry for you. We'll come and demo it, but we pay you. You pay us money. Correct, yeah. Dean, thank you so much. It's always an absolute pleasure to see your presentations. They are always so informative and simple to follow in a way, but always have a lot of depth of information. So thank you so much for that. Thank you so much to everyone for dialing in despite our South African challenges with our power outages. And have an awesome Friday tomorrow. And we'll see you again next week, everyone.